Today we're going to talk about rotations and dilations, and we're going to start with rotations first. So to describe a rotation, also sometimes called a turn, you need to know the center of rotation. We're just going to use the origin for our purposes, and then the angle of rotation, that's going to be a number of degrees, and whether the rotation is clockwise or counterclockwise. So clockwise goes around this way, counterclockwise goes around this way. Sometimes you might see these abbreviated as like CW for clockwise and CCW for counterclockwise, just in case you run into that. And then a rotation here, as we're going to do this, sometimes you might see written as like a little lowercase r, and then maybe let's say we're doing a rotation of like 90 degrees or something like that. It'll tell you a little subscript just to see if you get the notation like that. So if you see something like that, it's trying to tell you rotation and then that angle measure. All right, so what we have here as a little example is a rotation, and the center of rotation in this case is point P, and we're rotating it. It doesn't tell us the number of degrees actually in the diagram, but it would be matching up with this, and we could figure that out using a protractor if we needed to. And we'll be more specific about it in the questions that we're going to give you guys. All right, so slide down here to example 1. Okay, now regular pentagon is what I have here, and we're going to rotate this always about the center when we do these questions. So it says name the image. Remember, the pre-image is what you start with. So name the image of E for 144 degree counterclockwise rotation. Okay, first thing we're going to do really quick. If you guys remember going around in a circle to get these central angles, we're going to take 360 divided by the number of sides. Since I have a pentagon, that's 5. So each one of these, as you rotate here, the angle on the interior here that we're rotating is going to be 72 degrees. So if I take E as my starting point and I go 144, you just have to figure out how many 72s that is. So if I'm going counterclockwise, that's around this way, 1 would be 72, 2 would end up being 144, so that total angle measured there. So I would end up at point A. If I start at point N, this says 72 clockwise, so I'm going to go around this way. Each one of these is 72 as I go, so just 1 over. This would be the point T. And this last one's actually going to have us rotate an entire line segment. So here's PA. And this says 216 degrees. So if you grab your calculator just to check, if you do 72 plus 72, that's 144, plus 72 is going to give you 216. So I'm going to take this whole thing and rotate it, in this case, clockwise, 3 angles. So it would be, the PE would be 72, EN would be 144, and then NT would end up being the total for 216. So NT would be the new segment there. All right, now in the coordinate plane, there are rules, and you are welcome to use these on the assignments for rotations. And so I have each one listed here as counterclockwise. That's how it appears in the picture. The pre-image is a plain letter. The image is the letter with a little prime. It looks kind of like a little apostrophe. And it gives you each of these. So this is making a 90-degree angle counterclockwise with the origin. 180 is just a straight line, and then 270, half of that would be 180, and then 90 degrees more is 270. So some of these have the same rules. We'll get into that in 1 second, but I would keep this handy while you're working on the homework so you can look at these rules. Okay, so my original point P here, 5, 2, you can see when I rotate it 90 degrees, the y-coordinate becomes the x-coordinate, and it's the opposite. So this was positive 2, this is negative 2, This is negative y. The x-coordinate becomes the y-coordinate, and so this is going to be negative y comma x. Okay, so the other that's going to follow this exact same rule, this negative yx, is if I go 270 counterclockwise. So, or I'm sorry, clockwise. This is counterclockwise in the diagram. So if I go clockwise, here, this is 90. This around the other direction would be 270. So both of those have the same rule. Okay, now 180 is kind of a special case because it's exactly half of a circle in terms of your rotation. So you'll notice here the x and y are in the same spot. They're just opposites. So this is going to be negative x comma negative y. This is also going to be negative x negative y. And honestly, if you're rotating 180, it doesn't matter if you're going clockwise or counterclockwise because you're going to end up at the same point. And then 270 here, counterclockwise, this would be the same thing as 90 clockwise, are going to have the same rules. So you can see here, the y-coordinate becomes the x-coordinate, the x-coordinate becomes the y-coordinate, and it's negative. That's going to create a 270 counterclockwise or a 90-degree rotation clockwise. So I would keep these rules handy as you're going through these problems. Okay, so as you guys can see, I just kind of copied those rotation rules right at the top of the page there so I can look at them while I'm trying to rotate these figures here. So I have graphed two different triangles, and that's going to follow the points that are given, and we're going to do two different rotations as examples. So I like to just go through and I just do like one point at a time. So this one, we're going to take the triangle EFG and we're going to rotate it 90 degrees clockwise. All right, so the point E is 0, 4. So E prime with a rotation 90 degrees clockwise. So I'm going to come up here, that's going to be this. This is going to become 4, 0. Now, the x-coordinate 0, I can't do an opposite. 0 is its own opposite, so that's just going to be what we're going to put. Let's see. The point F is 2, 2. So F prime, this is going to become 2, negative 2. The y-coordinate becomes the x-coordinate becomes the y-coordinate and becomes an opposite. And then finally point G, the original is 4, 4. So G prime is going to be 4, negative 4. And I'll come over on the graph and just plot my image. All right, so 2, negative 2. I have 4, negative 4. This is the G prime, this is the F prime, and this is the E prime. And I just want to show you guys real quick how if you connect these back to the origin, they do make a 90-degree angle. So here's F, which I'm just going to connect with the origin. Here's F prime right here, also going to connect with the origin. And then you guys can see right there that makes a 90-degree angle. You could do that with each of the points. I'm just going to illustrate that for that one so you can see that 90-degree rotation. Okay, now this one doesn't matter if it's clockwise or counterclockwise. This is 180, so I'm going to use that rule in the middle. So L is the point 2, negative 3. L prime, we're just going to keep them both in the same spot and make them both opposites. M is the point 3, negative 5. We're going to keep M prime be negative 3, positive 5. And then you have N, which is 4, negative 3. So N prime is going to be negative 4, positive 3. And I'm going to come over and go ahead and put that on the graph. So negative 4, 3, that's my N prime. Negative 3, 5 is going to be my M prime. And negative 2, 3 is going to be my L prime. So here's my new triangle. And let me just show you the 180. I'll use the point L and L prime. So if you connect the point L back to the origin, and you connect the point L prime back to the origin, you can just see right here, we're just creating, this is clockwise, so technically I'm going this way, but I'm creating that 180 degrees, which is just a straight line. All right, the other thing we're going to talk about today is a dilation. So a dilation is going to be a little different than some of the other problems we've been doing, because all the other problems we've been doing have been what we call an isometry, where the original picture, your pre-image, and your image are congruent. Dilation is not going to happen that way. So a dilation says it's a transformation where the pre-image and the image, they're going to be similar, but they're going to be different sizes. Okay, in general, it says a dilation with center C and scale factor n is a transformation for which the following are true. The image of C is itself, C prime is equal to C, and then for any point R prime is on CR, CR prime is n times CR. So basically what you're going to do here is you're just going to multiply by the scale factor. Okay, and then the scale factor can go two different directions, so that's what I'm going to tell you about here. So if your scale factor is bigger than 1, you're never going to have a negative scale factor. That's not something that happens. If it's bigger than 1, you're going to have what we call an enlargement. And that means the image is going to be bigger in size. It'll be similar, but it'll be bigger than the pre-image. If you have a scale factor between 0 and 1, so what I mean by that, like if you have 1/2 or 2/3 or something like that, this is going to be called a reduction. So let me go through here and explain. I have one of each. So the image is going to be after the dilation has been performed. So for this one right here, I'll just leave the original not colored. The enlargement here is going to be the larger image. The original is going to be the smaller image there. It looks like a parallelogram, scale factor of 2. Now here, the original is much larger, and you can see the primes here on the inside. So this is 1/4 the size of the original. This is twice as big as the original. Scale factor. Okay, sorry, not twice as big. It's a scale factor of 2. All right, so just as like a little example, let's just say we had a coordinate point. This is how you perform a dilation. So dilation center 0, 0, find the image of this point A, -7, 0 for scale factor of 4. So if you see a capital D, little subscript will tell you what the scale factor is and then what point you want to dilate. The prime, literally all you have to do is multiply each of the coordinates by that scale factor. So this would turn into -28. Now 0 times 4 is going to stay at 0, and that's okay. So that can happen as you're going through some of these problems. Okay, so I just have one of each, and I've already drawn the figures I'm going to dilate, and I changed the point that was on the document originally because it looked a little odd, so I thought this would be a little bit more obvious. So for the first one I've got here on the left side, I've got a triangle ABC, and it says we're going to dilate with center at 0, 0. So all we're going to do is we're just going to take each of the coordinates. So a little dilation subscript, all 3 of these points. So your A prime, you literally just multiply by whatever your scale factor is. So this would become -2, 2. I'm just going to multiply everything by the scale factor, which is 2. This is going to become 4, 4. And this is going to become, oops, sorry, 2, -4. When I create this, this is going to be, since that scale factor is bigger than 2, this is going to be an enlargement. Whoops, if I could spell, and then we're going to go ahead and graph this here. So -2, 2 here, that's my A prime. 4, 4 here, that's my B prime. And 2, -4 is my C prime. Now, these two triangles are similar in terms of we could follow all our rules of similarity. They're the same shape, but they are different sizes, and this is an enlargement because the image is a lot larger than the pre-image. Okay, we're going to do scale factor here of 1/2. So this guy I've got a trapezoid. For my G prime, what we're going to do, just multiply everything by 1/2. So this is going to be -2, 1. Your H prime is going to be -2, -3. Notice the negatives do not change here. Your I prime is going to be 3, -2. And your J prime is going to be 1, 1. Now, it is a possibility on some of the homework problems that these numbers might be fractions, and that's totally fine. You're always welcome to just use your calculator if you end up with that. If you are working with the fraction, the homework assignment will either have it graphed for you if it's not a nice number, or you might just have to type in what the coordinates would be. So if you have to graph it, you can just kind of estimate if it ends up being a fraction. Okay, so -2, 1. Here's my G prime. -2, -3. Here's my H prime. 1, 1. Here's my J prime. And 3, -2 is my... Okay, guys, forgive me. I hesitated because I just realized I did not graph the point I right. So I'm going to pause the video and fix my diagram. Okay, now the I prime is correct because I was looking at the problem and not at my graph. So sorry, the I should have been there. That's 6, -4. Now, when I graphed this, this was accurate. So this is 3, -2, and that is going to be my I prime. And then we'll go ahead and connect. Here, this is a reduction. You guys can see my image is smaller. In case that asks you, this is going to be reduction. That number is a scale factor that's between 0 and 1. Okay, and then these last two, just examples of how to figure out what is the scale factor. So let's say I don't have a graph, let's say I have a picture, and on this first picture, my original is going to be this triangle with the 4, the smaller triangle, and then my image is going to be the larger triangle. Okay, if you are trying to figure out what the scale factor is, you've got to have the similar sides, so the 4 and the 10 are the bottoms of both of those triangles. What you want to do here, I'm doing something to 4, I'm multiplying that by the scale factor. Sometimes you'll see that represented with an N, and I'm getting 10. So what am I multiplying 4 by to get 10? And that should give me my scale factor. Now in this case, I'm just going to divide both sides by 4, and if you can, go ahead and reduce that fraction, and my scale factor there is 5/2. So if you take 4 times 5/2, that'll be 10. That'll be your scale factor. Now let's move over to this one. Really, you just need one set of points. You need the image and the pre-image. So for my A here, let me just figure out what this is. We're going 1, 2, 3, so -3, and then also -3. And your A prime here, I'm going 1, 2, 1, 2, -2, -2. So we're going to compare, like, what are we doing to these numbers? So -3 is my original. Make sure you get your original. Your original multiplied by your scale factor is going to be equal to your image. So what am I doing to that -3 to change it into a -2? And the negatives should always cancel out if you have something like that. You can't have a negative scale factor. So this would just reduce to be 2/3. Now, if you wanted to, you could check another point. So maybe I'll check, ooh, these don't look like they're on nice numbers. So that's a good idea that I picked the A. And I'm multiplying by 2/3, and that's why if we don't have something that's divisible by 3, it's not going to be on the nicest of numbers. So let me just try this. We're going to kind of have to estimate this here. Make sure you're picking points that go right through a corner when you try to do this problem. So if I look at the C here, this is 1, 2, 3, 4, 5, and then I'm going down 3. So if this is my scale factor, is 2/3. What I would do here to get the x-coordinate, it would be 5 times 2/3, straight across the top, straight across the bottom. You do not need a common denominator. And then if I do -3, I'm just turning it into a fraction by writing it over 1 times 2/3. This would be -6/3. Now, this is just -2. And if you look at my c value, it is right on the -2. 10/3, I'm going to go ahead and leave that as an improper fraction. If you want to think about that as like a mixed number, this would be 3 1/3. So I'm just going to kind of look at the graph. This is over 1, 2, 3, and a little bit more, so that makes complete sense. So if you do have a scale factor and you got to multiply, go ahead and leave your result in fraction form. So this would be, my c prime would end up being the point 10/3, whoops, sorry, and then -2.